Okay, welcome back. So in this video, we're going to look at 1.12a, translations of functions. Um, so from the algebras, we should already know how some of these transformations already affect our graphs. So just a quick recap on that. Uh, when we have f of x plus or minus a number, but plus, sorry, minus h plus k. This is going to be the general form of our transformations. So when we see x plus h, that means we're going to go left h units. When we see x minus h, this is going to be right h units. So left, right. And then when we see k, so that plus k is going to be up k units. And if we see minus k, this is going to be down k units. So really, it just depends on what the values are for, whether we see a plus or minus a number, and then plus or minus k, so another number. The way that I like to remember this is that usually when we're talking about, so you know how like we in English we usually say things in a particular order. Um, Usually, at least I do, I say left, right, and I say up, down in that order. So anytime I'm giving directions or something like that, I usually say left, right, up, down in that order. And what's nice about that is that left is plus, so plus h, and right is minus. And with k, up is plus and down is minus. So anytime I'm thinking about this and trying to remember in my head, okay, if I have plus h or minus h, the one that's really intuitive to me is plus k and minus k. Uh, Plus goes up, minus goes down, but usually when we're thinking about direction on the x-axis, we associate to the right being in the positive direction and the left being in the negative direction, but it's counterintuitive when we're doing translations. So, and if we want to remember that, uh, plus minus left right, that's how I do at least. So I figured I'd share that with you. And so just remember that when we're working on the inside of the parentheses here, it does the counterintuitive thing of what you think it should do. So we'll see that in 1.12b when we're looking at those transformations as well when we're doing horizontal dilations. So, anyways, with that said, let's look at the transformations that we have on both of these or all of these functions. So with the minus 2 on the inside, that's going to correspond to right 2 units. And then the plus 4 is going to correspond to up 4 units. So every single point on this graph is going to move right 2 and up 4. So this point right here, 1, 2 to the right, 1, 2, 3, 4, it's going to be right there. And all the other points on the graph will do the same thing. So usually what I like to do is graph all of the, what I consider the important points. So particularly these 4 points are going to all move in the same fashion. So right 2 up 4. So if we move this one right 2 up 4, 1, 2, 1, 2, 3, 4, this point goes right here. This one, 1, 2, 1, 2, 3, 4, right here. 1, 2, 1, 2, 3, 4. And so all 4 of those points, when they're moved, make this shape. And if we just connect them, we can see that the function did not change at all. It's still the same shape. It's just been translated to the right and then up. So it's still the same shape. It's just moved around a little bit. Now, what about for number 2? We have minus f of x plus 3. So when we're doing transformations, we want to apply them all from left to right. So first, we want to apply the transformation of this minus f. What that's going to do is this is going to be a reflection over the x-axis. So what we're going to do is it's going to flip the y-coordinate of every single point. So let's again look at these 4 points, and let's see what happens. So if we flip the y-coordinate of this point would be negative 4, comma 0. If we flip the y-coordinate, this would be negative 0. And so negative 0 is still 0, so this point actually stays the same. This point, on the other hand, this is negative 2, comma 2. If we flip the y-coordinate, it's going to have the same x-coordinate, but now it's going to be down here. So we see this point go right there. And then, same thing over here, flipping the y-coordinate, this is going to go down here. And flipping the y-coordinate over here, it's going to stay the same. Now, so we should see that it'll look something like this, but I don't want to fill it in quite yet because we're not done. We have to move it to the left 3 units as well. So if we move this left 3 units, now let's move these 4 points. So I'm going to mark those each. Now we have to move these 4 points to the left 3 units. So doing that, we have 1, 2, 3, left 1, 2, 3, 1, 2, 3, 1, 2, 3. And so I'm going to erase the old points that we made just so it's clear what we did here. But our new function, our new graph, I should say, will now look like this. And so we're done. Okay, what about this function? So g of x, again, we're going to reflect it over the x-axis, and we have to do that first. So reflecting it, we're just flipping the y-coordinate. This point's going to stay the same, and this point's going to stay the same. However, this point right here is now going to move up here. So let me mark that. As mentioned, this point's going to stay the same, but this one over here is going to go all the way down here. So I'm going to mark that there. So if we just reflect it, our function would look something like that. But now we have to move it up 5 units. So we're going to take all of these points and we're going to move them up 5 units. So this one, 1, 2, 3, 4, 5, right there. This one, 1, 2, 3, 4, 5, right here. 1, 2, 3, 4, 5. And then this one, 1, 2, 3, 4, 5. And so, connecting all of those points, our new graph for g of x will look like that. And so we're done. All right. So now looking at number 4. So this minus 5 is telling us that we're going to move to the right 5 units and then down 3 units. So let's do right 5 units first. So moving everything to the right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Okay, so we should see that our function should look, so far, if we just move it right, like that. And now we're going to move it down 3 units. So moving everything down 3 units from this transformed function, this intermediate step. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so our new function for g, or our new graph for g, will look like that. Number 5 is pretty easy, because all we have to do is move all of our points down 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And so, since that was the only transformation we had to do, we can just connect this. And so our graph looks like that. And the last one, g of x, has 3 transformations happening here. First, we have to reflect it over the x-axis. So let's look at all of our points and let's negate their y-coordinate. So for this point, it's now going to be up here. So I'm going to mark that there. Other important point we should note is this one. So since this is a y-coordinate of positive 3, it's now going to have a y-coordinate of negative 3. Same thing, this one. This one's right next to it, so y-coordinate over here. And last one, this is a y-coordinate of positive 1, so it's going to become a y-coordinate of negative 1. So our function, just by doing the reflection, should look something like that. However, we still have 2 more transformations to do. This minus 3 is going to move it right 3 units. So right 3 units, let's do that. 1, 2, 3. And then these two, 1, 2, 3. 1, 2, 3. 1, 2, 3. And then moving this up 1 unit. 1 right there, so just up 1, up 1, up 1, and up 1. So our new function will look like this. It'll be these points connected right there. So yeah. So that's 1 through 6 and how we can graph these, well, do our transformations graphically. What about 7 through 10? Okay. So these, now we're going to do this algebraically. So we know that f of x for number 7 is given by 4x plus 3. And g of x, we want to find, it's given by f of x plus 5. And we want to find, well, what is g of x? Well, if we know that f of x is equal to 4x plus 3, g of x is just going to add 5 to this. So I'm going to say that g of x is equal to 4x plus 3, since we know that's what f of x is, plus 5. And we really don't need these brackets. I'm just going to be very explicit by using the brackets, so that we see that this f of x got swapped out for the 4x plus 3, and then we're just adding 5 to it. But we don't really need the brackets. We can just write this as 4x plus 3 plus 5. It's better to have too many brackets than not enough, because especially once we get to more complicated transformations like we'll see in 1.12b, it'll be kind of necessary to use brackets. In fact, I have a slightly different approach than I taught in the lab that I would like to use. But we have 4x plus 3 plus 5. That's just going to give us 4x plus 8. And so this is g of x. Now what about this one? We have that f of x is equal to 2x minus 5, and we want to find g of x, and it's given by all of this. I think the first thing we should do is figure out what f of x plus 3 is. So when we evaluate f of any number, we just replace the x wherever we see an x. So like if we did f of 2, we would just replace this x with 2. But since we're doing f of x plus 3, we have to replace this x with x plus 3. So off to the side here, I'm going to evaluate f of x plus 3 as equal to 2 times x plus 3 minus 5. So again, we just replaced this x with x plus 3, which is why we have 2 times x plus 3 minus 5. If we simplify this, this will be 2x plus 6 minus 5. And this is 2x plus 1. So if we know that f of x plus 3 is equal to 2x plus 1, now it may be simpler to figure out what g of x is because we already know that all of this right here is just equal to 2x plus 1. So we see that g of x is equal to 2x plus 1. And then we're just going to add 4 to that. And again, we don't really need the brackets, but just want to be explicit about what all we're doing here. But the 2x plus 1 plus 4 is going to give us 2x plus 5. And so this would be our final answer. So what about for number 9? We have x cubed plus 2x squared for f of x. And for g of x, we want to find negative f of x. Again, off to the side here, I'm just going to evaluate negative f of x so that we can see what's going on here. And negative f of x is just going to be negative whatever f of x is equal to. So we have x cubed plus 2x squared. And so that means that we just have to negate all of our terms here. That's going to be a negative x cubed minus 2x squared. And so if this is negative f of x, now we just need to add 5 to that. And so as you do this more often, you'll get more comfortable doing these function operations without having to put the brackets or whatever. But again, just to be explicit, negative x cubed minus 2x squared. And then we just want to add 5 to that. This is negative x cubed minus 2x squared plus 5. And this is our final answer. Now the last part of this, for number 10, So they want to do x minus 10 or x minus 2, but we have to replace x in f of x with x minus 2. And so first, let's figure out, I'm just going to calculate this f of x minus 2. So f of x minus 2 is going to be equal to 2 times x minus 2 squared minus 3 times x minus 2 plus 1. And now we have to square x minus 2. X minus 2 squared is going to be x squared minus 4x plus 4. Then we have minus 3 times x minus 2. Plus 1. Let's distribute all of this stuff here. That is going to be 2x squared minus 8x plus 8 minus 3x plus 6 plus 1. And combining like terms, we have 2x squared minus 11x plus 8 plus 6 plus 1. So that's going to be plus 15. Is that plus 15? Yeah, that's plus 15. All right. So we have plus 15. And so that's f of x minus 2. And remember, g of x is just all of that, I'm going to move this party over here. G of x is just all of that. So the 2x squared minus 11x plus 15, all of that plus 5. And so if you take away the brackets and combine like terms, it's just going to combine this 15 and this 5. Your final answer is going to be 2x squared minus 11x plus 20. And that will be your final answer. Okay, so let's move on to the next page. So for the next page, starting at number 11, we have a table of values, and we want to find g of 5. So first, let's just note that we're already given that g of x is equal to f of x plus 2. So if we find g of 5, this is just going to be g of 5 is equal to f of 5 plus 2. Well, we're already given what f of 5 ought to be. So f of 5 is just saying that, well, what's the y value when x is equal to 5? Well, when x is equal to 5, f of x is equal to negative 2. So this gives us negative 2 plus 2, and combining this, we get 0. For the next one, we want to find g of 1. So to do that, again, g of 1 is going to be equal to f of 1 plus 2 minus 3. Well, 1 plus 2 is 3, so f of 3 minus 3. And what is f of 3? Well, let's look at our function. When x is equal to 3, f of x is equal to 8. So this is equal to 8 minus 3, and that's going to be equal to 5. Lastly, we're going to find g of 4 for number 13. So g of 4 is equal to negative f of 4 minus 2. And so 4 minus 2 is 2. And now we have to figure out what f of 2 is. So when x is equal to 2, f is equal to 21. And remember, we just need to negate that, so we get negative 21. And there's nothing else that we need to do to simplify that, so that is our final answer, negative 21. All right. And now let's look at the domain and range transformations. So given the graph of f, so it has a domain of negative 5 to 3, not including negative 5, blah, blah, blah for the range. So g of x is equal to f of x plus 5. Well, remember, x plus 5, that's going to move us to the left 5 units. And so if we're moving to the left, that's only going to affect the domain. So we're not moving it up or down. If we move it up or down, that'll affect the range. But if we're only looking at the domain, and we're only changing the domain, left 5 units is going to, let's see, think about that for a second. If we have some function and we're moving to the left, on a number line, if this is 0, 1, 2, blah, 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 if we're moving to the left, the numbers are going to get smaller. So we're going to subtract 5 from all of the values in the domain. So our domain is going to go from negative 5 to 3. If we subtract 5 from all of the values, that's going to be a new domain of negative 10, negative 2. So this is our new domain. So negative 10 to 2, not including negative 10. Okay, what about this next one? We have a graph of f as a domain of 0, 5, range of negative 10 to 4. So this function for g, that's going to be -2. So -2 is going to move it to the right. So if we're moving it to the right, we're going to add 2 to all of the values in the domain. So I'm going to just write that a +2 over here. And then the +4 over here, that's going to move our function up. So we're going to add 4 to all of our values in the range. So our domain goes from 0, 5, and if we add 2 to everything, new domain is going to be 2, 7. And for our range, we start with -10 to 4, and if we're adding 4 to all of our values, that's going to make it -6 to 8. And so this is our new domain and range. Now what about number 16? So first, we're going to negate f. And so remember, when we negate f, that's going to be, I'm going to write an arrow. So when we do that, that's going to be a flip or a reflection over the x-axis. So that's not going to change our function's domain, that's actually going to change our function's range. So we have to negate y values, aka the range. So we'll deal with that in a second. The +3 is going to move it right 3 units. So if we're going to the right, oops, sorry, not right. Oops, see, even I mess this up sometimes. I have to consciously think about this every single time. That's going to be left 3 units. Let me make sure to do the others right. Okay, so yeah, that one's right. This one's left. Okay, just making sure. Left 3. So if we're going left 3, that means we're going to subtract 3 from elements in the domain. And then that +5, it's going to move us up. So we're going to +5. So let's do the domain first. So for the domain, we start with -2, 4. And the only thing that we're doing that's affecting it is moving it left 3. So if we subtract 3 from everything in the domain, that's going to give us -5, 1. And that was the only transformation that was done to our domain. Now what about our range? Our range, we start off with -1, 8. And then the first thing we have to do is flip all of the y values. Basically, that's going to give us 1, -8. So just flip the signs on this. And then we have to move it up 5 units. So then if we move it up 5 units, we have to add 5 to everything here. That's going to give us 6, -3. And the last thing we have to be careful about is that this is still in the correct order. Well, anytime we flip the, anytime we do a reflection, we have to be mindful of that. So 6, -3 isn't correct. We need to write that from least to greatest. That's going to be -3, 6. So -3, 6 is actually our new range. But new range, new domain. And again, to be explicit about the other one, well, I didn't write the new range for this one because we didn't change it at all, but this is our domain, our range is still the same. And for this one, this was our new domain and our new range. So, yeah, that's how we do domain and range transformations. Let's look at number 17. So first, let's identify what the transformations are here. The first one we have is this minus f. So remember that's going to be a reflection over the x-axis, so we're going to negate all of the y values. So this point right here, just negating the y value, is going to go down right there. This point is the up 4, so this is going to go down 4. This is up 2, so it's going to be minus 2. This is going to go right there. This is going to go right there. And so this is what our function looks like so far, just by negating the y values. Okay, but we also have to do the other transformations. We're going to do left 3 and then up 2. So left 3, I'll do this each point. So 1, 2, 3, up 2, 1, 2. I'll make a really big point so that I can differentiate that from the smaller ones. So this point went right there. This point, I'm going to do 1, 2, 3. Nope, sorry. 1, 2, 3, 1, 2. Big dark point. 1, 2, 3, 1, 2. Another big dark point. 1, 2, 3, 1, 2. And then 1, 2, 3, 1, 2. And so our new function for g is going to look like that. So that takes care of A.